Hey everyone, welcome back to our next lesson in the probability unit. This one is called probability and counting methods. So what we're doing here is we're going to start mixing together our last unit and this unit together, which will come with a little bit of challenge, but nothing too crazy. Okay, how we're going to start this lesson is I'm going to get you to imagine that you've got two different dice. One's a blue one, one's a red one. You're going to fill in this table here. We're going to use this table over our next few lessons together, so let's fill it in nicely. So I'm going to get you to hit pause, and then I'm going to get you to go ahead and answer the questions on the page. And when you're done, then I'm going to get you to come back to the video, hit play, and we'll chat and make sure that everything went okay. So I'll hit pause now, and I will see you in a few minutes. Okay, hopefully you took the time to fill in this chart. It's nice that I was able to do it all in red and blue, and we will be using this over the next few lessons, so we'll keep referring back to this. It'll save us some time instead of filling the chart out over and over. So hopefully you answered the questions as well. So first question says, how many combinations did you find in total? Well, there was 36 because we listed every single possible outcome. Is there a better way to do this? Absolutely. We could use our friend the fundamental counting principle, which says simply 6 times 6 is 36. So we definitely always need to know the total amount of outcomes when we're doing probability. Now, first question says, let X be the event of rolling a sum of 7 on the 2 dice. Okay, I'm going to go ahead and I'm just going to put pretty hearts on top of them. So right there, there's my sum of getting a 7. The next question, B, says put probably a Y over top and tell me what's the probability of getting a sum of 9 or greater. Okay, I'm going to go and put stars on these. 9 or greater, at least 9. There we go. Perfect. Okay, so you should have those. You have them labeled with X's and Y's. So what's the probability of rolling a sum of 7 on the 2 dice? Well, that was 6 out of 36. Now I'm going to just leave that like that. Instead of reducing, I know I can simplify that down to 1 over 6, but for now I'm just going to leave it as 6 over 36. What was the probability of rolling a sum of 9 or greater? Well, if I go back and I count, it was 10 over 36. Again, I'm not going to simplify that. And there's a reason why. There we go. Okay, not so bad so far. Complementary events. This is where, remember, the complement means we're talking about what we want and what we don't want. So let's C represent the event of rolling doubles. So it says go back and circle all the desired outcomes. Well, I know that there are 6 ways for me to get doubles. 6 out of 36. Let C prime, remember prime right there means the complement. That would be not rolling doubles. Well, what I know then is if there's 6 ways for me to get doubles, I immediately know then there's 30 ways for me not to get doubles. The other way to do this is to say, look, P C naught is 100% of the outcomes minus what I don't want. And what I don't want is that, getting doubles. And guess what? These two things are equal. C says, what's the sum of probability of C and probability of C prime put together? Well, if I add those together, I'm going to get 36 over 36, which is 1. Will this always be so? Absolutely. That's 100%. If I add together what I want plus what I don't want, That's all possible outcomes. That always has to add to 100. Take a peek in our Venn diagram. This highlights exactly what we're looking for. If here is getting doubles, and on the outside is not getting doubles, if I add these two regions together, there's not doubles. Here's doubles. If I add these two regions together, there's nothing blank. Everything is accounted for 100% of my items. So yes, this must always be true. Now, way back when we were little guys and gals in elementary school, one of the handy ways to answer these questions was to draw a tree diagram. And it still can help you out. If I'm stuck on a question, it's not a bad thing to try. So remember how a tree diagram works. Really what you do is it says we've got a tiger and it's having 3 cubs, and lists the possible order of having the 3 cubs. So cub 1, cub 2, cub 3, and then the order. So I can go start with a male. So I go male, then I have a male or a female, then a male or a female. And I keep going, male or female, male or female. And when I'm done my tree, then I'm able to list out my set. The quick problem here that you already noticed is just how much you may have to draw when you're doing these things. This is a tiger having only 3 cubs. And drawing this thing out starts to become cumbersome already. So now I want you to picture what's going to happen when we have a tree with way more than just 3 animals in it or 3 different children. This is going to be a big, big cumbersome problem. But writing out the sample space is really, really handy. Now, there's definitely 8 different outcomes. Why does order matter here? Order matters because I can tell the difference between this and this, right? In the first one here, the female is the youngest, and in this one, the female is the middle child. So there's definitely an order that plays into this. A, determine the probability the litter of 3 cubs having exactly 2 males. So, probability, 2 males. Well, I go back up and I count how many times I get exactly 2 males. That'll be 3 over 8. Notice I'm not going to put that in my calculator and get some decimals. If there are no rounding instructions, I do not round. Probability, at least 2 females. Well, what that means is, remember words, at least means I'm getting 2 females or 3 females. At least is my minimum. Well, again, I just go back up and count, and that's 4 out of 8 ways, or I could simplify that to 1 out of 2. Okay, determine the odds. Okay, I need to be careful here. As soon as I see that word odds, remember back from our previous lesson, I'm a big fan of writing out FAT. There's 8 things in total. I want at least one of the 3 cubs is a boy. At least one of the 3 cubs is a boy. Well, if I go back up and count, I would see there's 7 outcomes where there's at least 1 boy, and there's only 1 outcome where there isn't a boy, all females, right? So I like to list that out, and so now odds, at least 1 is a boy. At least 1 boy, 2 no boys. Well, that would be 7 to 1. Again, I like to write out what my odds are telling me or what I'm trying to express to someone right here, because that way if I make a small goof, which I'm prone to do, at least the person reading my work says, hey, I know what they were trying to do, even if they made a simple arithmetic error. One last example, and this is where we get a little bit more difficult, but not too bad. It's really important when I'm looking at these questions, and I start to read it and I go, hey, I've done something like this before. So I've got Joey and Steve are trying out for the basketball team. We're putting 13 players on the team from 21 that are trying out. And it says we're picking at random. So this is a combination because I'm not assigning roles. I'm not assigning roles, combination. So determine the probability that Joey and Steve will both make the team. Here's what I'm going to do. Forget about probability for a second. Let's go back to last unit. How many ways could Joey and Steve make the team? How many ways could they make the team? So let's just do Joey and Steve first. Here's Joey and Steve. Joey and Steve make the team. Well, it's a combination because I'm not assigning roles. There's two of them. I need both of them. Right? There's Joey and Steve. But don't forget, I need Joey and Steve and 11 more people on this team. So what have I got left here? Well, there were 21 students, right? And I need to figure out there's 13 people that are going to be on this team. Well, that means they selected, there is 11 more people, and I selected 11 more positions on the team, and I selected 9 of them. Now, what I'm going to say is, what's the total amount? What's the total amount? How many ways could I just make the team? Well, if I just want to make the team, that's 21C13. 21 people on the team, 21 people to select from, 13 people on the team. So now if I want probability, here's what I'm going to do. The probability that they're on the team, that I get these two on the team, I'm just going to take these two answers and divide them. So this first one here is 55. This second one here is a large number, 203,490. So if I want the probability they're going to make the team, I'm simply going to divide these two things out. So when I'm attacking a question like this, what I say is, I'm going to break it up into almost 2 questions. I'm going to go back to the last unit because I can answer this easily. How many ways can Joey and Steve make the team? How many teams are there in total? And now what I'm going to do is I'm going to put them together to find that probability of both of them being on the team. Let's try this again. Determine the probability that neither Joey nor Steve make the team. Okay, so again, I'm going to break this up into 2 questions. I want not Joey and Steve. Well, there's 2 of them. I don't want any of them. Well, that means I need 13 more players on the team, and I need 11 of them, right? And then my total amount, well, my total, there's 21 people, and there's 13 people there that I need. And I just realized I've screwed up. So right here, I'm going to change this to say there's another 19 people that aren't Joey and Steve, and I need 13 of them. Done. Perfect. Now I've got all 21 people accounted for, and I've got all 13 players on the team. Okay, and I'm also quickly realizing, looking up at my previous answer, hey, I screwed that one up too. I'll fix that in a second. Okay, so do it as 2 separate questions. Put this in my calculator. So this is a big number. This is 27132. 21C13, I already know the answer to from above. So what's the probability that neither of them make the team? So now I'm going to change and put these two things together. So not Joey and Steve. So probability not Joey and Steve. Well, that's my first answer over my total answer. Okay, I need to go back and fix A. I made a little goof. And here's how I know I made that goof. And we'll pretend that I did it on purpose, but I totally didn't. I didn't notice it at first. But I don't have a good way to check my work. Remember that from the previous unit, but I do have this minor way to check my work. If I add those two numbers together, that should be 21 people accounted for, because there's 21 students that are supposed to be on the team. And then if I add these two, I add those together, there's 13 people. Yeah, there's 13 people that I'm supposed to be on my basketball team from the 21. Well, if I go back to my previous question, I immediately see I screwed it up. Right there. I don't have everybody accounted for, do I? That's 13 people. And here, if I add these two up, that's just 11 people. That's nothing. I totally screwed this question up. So let's go back and try this again. So nothing wrong happens. Make mistakes. Let's go fix it. So what I screwed up was right here. So if there's two people, Joey and Steve, that are making the team, that means there's still 19 people left for me to put on the team, and I need 11 more. That's going to give me my 13 people on the team, and I've used all 21 people. So let's just go fix that. So 19C11, this is going to give me 75,582. Now I can answer the question properly. Here we go. Okay, so it never takes too long to just go and see, do I have everyone accounted for? If I had done that in the first place, I would have noticed that I had screwed up, right? Now when I go to check, I say, look, 2 plus 9 is 21. I've got all students accounted for. 2 plus 11 is 13. I got all players on my team. I'm good to go. Okay, so when I'm encountering these probability and counting method questions together, I need to start asking myself, does order matter? In this case, it doesn't, because there's no assigned roles. The second thing I need to do, or how I at least like to do the question, is break it up into two parts, then do the final question together by dividing my two parts. There it is. Okay, I hope that was okay for you, and I will see you next time. Adios.